Okay, let's do a few examples to kind of solidify what we've discussed. So, for the radical product property, if we take an example like square root of 3 times square root of 12, remember we said square root of a times square root of b equals the square root of a times b. So, square root of 3 times square root of 12 is the same as square root of 3 times 12, which is the square root of 36. Well, the square root of 36, 36 is a square of 6 times 6, so the square root of 36 is 6. Another example, we can take the square root of 64. Now we're going in the opposite direction. So that would be the same as the square root of AB equals square root of A times square root of B. So square root of 64 would be the same as the square root of 16 times the square root of 4. Now, 4 times 16 is 64. So square root of 16 is 4. Square root of 4 is 2. 4 times 2 equals 8. So by applying this property, we were able to resolve these radicals, these square roots. Let's take another one. If we had 3 times square root of 2 times the square root of 8. Alright, we said that we can, if we have a square root of one number times a square root of another, we can put them both under the same square root sign. So this can become 3 times square root of 2 times 8, which is 3 times square root of 16. Square root of 16 is a perfect square. 16 is a perfect square, so its square root of 16 is 4. So we have 3 times 4. 3 times 4 gives us 12. So by combining these two, we were able to come up with a 16, and it's a perfect square, so the square root of it is 4. So 4 times the 3 on the outside gives us 12. One more example. We have 5 times square root of 3 times 2 times square root of 3. Now again, we said we could combine two numbers under square root signs. So we can take 5 times 2 is 10, and we can take square root of 3 times square root of 3, put them both under the same sign, 3 times 3. So that's 10 times the square root of 9. 9 is a perfect square, and it's 3. So we have 10 times 3, and that's 30. Whenever we have a number times itself, we can really remove the number, we can cross that out and put a 3 on the outside. We'd have 3 times 10 is 30. Okay, so those are a few examples of the product property. Let's try a few of the quotient property. Quotient property, we have the square root of a over b is the same as the square root of a over the square root of b. Or we can reverse it. Square root of a over the square root of b equals the square root of a over b. So there's our rule for the quotient property for radicals. So let's take a few examples. So if we have the square root of 64 over the square root of 36, that's the same as the square root of 64 over 36. And if we factor that, we've got a 4 that can come out of both of those. So we have a 4 times 16, and we have a 4 times 9. So square root of 4 is 2, square root of 16 is 4, square root of 4 is 2, square root of 9 is 3. 2 times 4 is 8, 2 times 3 is 6. The common factor of 2, 2 into 8 is 4, 2 into 6 is 3. So this is a way that we're helped by manipulating these radicals into different forms. Alright, let's take another example. We can take the square root of 9 over 16. That's the same as the square root of 9 over the square root of 16. Square root of 9 is 3, square root of 16 is 4. So we were able to solve that by both were under the same radical and we split them up. Alright, another example, we can do square root of 36 over 3. Now in this case, we can just resolve the square root of 36 is 6. 6 divided by 3 is 2. Another example, we have 4 times the square root of 2 over 9. Well, we can split that up, so we can say 4 times the square root of 2 over the square root of 9. Square root of 9 is 3, so we have 4/3 square root of 2. And that's as far as we can take that one. Another example, we'll take square root of 3 over 75. Now this is a case where the best thing to do is to first see if there's anything common between these that we can divide out. And we can take the 3 into 3 is 1, 3 into 75 is 25. So we end up with the square root of 1 over 25. Now, both of these are perfect squares, so we can split them up. Square root of 1 over the square root of 25. Square root of 1 is 1, square root of 25 is 5. So these are some ways that we can use the quotient property to manipulate the radicals. And of course, if you get lost, you can always use your calculator and take the square root or whatever root it is of the number you're concerned with.